Hey, welcome to Tech Tuesday. This is Rick Husey. Today I'm going to be talking about DOCSIS PNM and specifically about the mobile application that goes with our PNM software. And I'll be right back. Hey, thanks for joining me again. This is Rick Husey from Zecorum, and I'm going to be talking today about DOCSIS PNM and the NimbleDis PNM mobile app. If you're watching right now live, you can, if you'd like, you can ask questions through the chat feature in YouTube, and I'll try to answer those as best I can. If there's something I can't answer, then I'll get the answer for you. But basically what I'm going to be showing you is how, if you're a Pre-equalization Analyzer user, which is our DOCSIS PNM application, how you can get the app, sync it up with the desktop application, and then some of the features that are available in that. So again, if you want to, you can go ahead and chat at me, and I'll try to answer any questions you may have during that. At the end here, or at any time during, if you like this video, go ahead and give it a thumbs up. You can always subscribe to our channel by hitting the subscribe button and then ringing the little bell to get notified whenever we are doing a video, whether it's live or whether we post something. So let's go ahead and get started and talk a little bit about this application. So first thing that you would do, this may look familiar to you if you're a Pre-equalization Analyzer user, it's a desktop application, and the first thing that you've got to do is open this up before you open up the mobile app, because you're going to need to sync the two of them. So you see here I've got a little arrow pointing to the help menu, and you're going to go ahead and on that menu click that, and then you'll see a sync mobile app selection, and you're going to want to select that. When you select that, it's going to bring up a barcode, and you're now going to go ahead and, if you could have already downloaded the app, or where you're going to get that app is going to be, go to your Google Play or to the Apple Store, and you're going to look for NimbleDis PNM. Should be easy to find. You're going to install that, and once it's installed, open that up, and you'll see the menu there, and on that menu you'll see in the a couple of places you can tap on your profile. You'll see down at the bottom there in the bottom right corner that you've got a little profile icon, or you can also swipe down and you'll see a bigger profile icon. You can tap on either one of those. When you do that, it's going to give you a choice to scan the QR code. So you've got the QR code now up on your desktop or laptop, and you're going to tap that scan QR code. And then once you do that, it'll pull up your camera, and it'll pull up a little white box, and you're just going to hover over that QR code on your screen, and it's going to immediately sync that up. So that's very easy to do. It'll sync up, and now what that does, I forgot to mention, I think you're going to have to log into the mobile app as well. So you've already got an account on Pre-equalization Analyzer. You're going to log into the mobile app with the same username and password, and then you're going to go through this process of scanning the QR code. So again, you'll come back to the main menu in the mobile app. Now, when you do this, this is going to log you out. You're logged into the desktop application. You're going to get logged out of that because you can only be logged in to one instance at a time. So if you're on the mobile app, it's going to log you out of the desktop app. If you're in the desktop app and you open the mobile app, you log out of the desktop app. Is that what I said? Yeah, and vice versa. So if you're on the mobile app and you log into the desktop application, it will log you out of the mobile app. So at this point, it will probably log you out of the desktop application. We're going to be looking at what's on the mobile app. So you can see here some of the choices that you've got. Again, the last thing down if we swipe down would be the profile. So this is pretty much what you've got here. So the first thing we see is install new cable modem. And unfortunately, you can't push this and have it actually drive the truck out and install the modem for you. It doesn't do that. But what this does is if you have a technician that's out in the field, if you're the technician or whatever, that you go out in the field and you're installing that cable modem, when you're done, you've got everything connected, you can then tap this, and this is kind of a nice feature that maybe a lot of people don't realize what it does. It's going to then go ahead and run a test. It's going to, first thing you need to do is let it know what cable modem you're installing, and you can search for that. You can also scan a barcode to pull that up, and then you're going to click or tap the install modem, and that's going to generate a birth certificate. So what that's going to do, and this is an older screenshot. I don't have the ability to actually install modems because I don't have my own cable plant. But with this older screenshot, you get an idea. It's going to run through a series of tests on this modem, and it's going to let you know, did that modem pass or fail certain things. And it looks at both your normal SNR kinds of things, but also your pre-EQ PNM kinds of statistics. So upstream MER, cable modem transmit power, which in this case it's saying it failed that test, micro-reflection level, PNM metric, group delay, a PNM metric, and then also your in-channel frequency response, another PNM metric. So it's checking this modem, making sure that everything looks good from SNR or signal ratio, SNR as well as well, just RF signals, and then as well as your pre-EQ or PNM kinds of things. And if everything passes, it's good. If you have something that doesn't pass, like this transmit power, then you may want to address that and see if you can figure out why that's happening. And this birth certificate is stored in the system, and then if you make some changes and then install the modem again, it's going to record another instance of the birth certificate that's going to be dated. You'll be able to see the person who installed it and the date. So again, it's a very nice feature to have, because one of the first things you want to do is make a good first impression. So if you're installing that device out in the field, you want to know that when the technician leaves the home, at least at that point, everything was working good. Now, you never know what's going to happen after that. I mean, they may install it, they could run this test, everything looks great. Then, a cold front comes through, the temperature drops, it rains, whatever, and things may get a little wonky again. But at least you know when the technician left the home, everything was looking good. You can't control for environment, or you can't control for what the customer does after the technician leaves the house. Maybe they want to move the modem and do something to it. But at least you know then, when they left the house, everything looked good. So, and this can be pulled up, of course, in the mobile app you can pull up birth certificates, but also in the desktop application you can pull up birth certificates. So your administrative people, for example, can check and see how the installs are going. It's a great way to keep on top of the installs, maybe to provide some training opportunities if you're seeing lots of birth certificates that are not passing. So anyway, that's that feature. Again, not a lot of folks know about that. Upstream Analyzer, this is a optional module that is available within the Pre-equalization Analyzer interface, and this is a return path spectrum analyzer. And then in the desktop application, there's also Upstream Monitor if you have this module, which looks at historical upstream spectrum as well. And on this particular feature, when you tap that, you're going to select a node, and then it'll give you a list of nodes, and you're going to pick a node. And at that point, what it's going to do basically is it's reading the spectrum as it's passing, and this is live, as it's passing through the CMTS. So rather than have to have expensive return path monitoring equipment in your head end, and then complicated cabling, and maybe having to move cables around when you want to look at specific channels or whatever, you don't have to do any of that. This will read it right from the CMTS, and you can see here you've got the gray areas are showing you where your DOCSIS carriers are, and you can look and see if there's any noise under the carrier, those kinds of things. So this is a really nice feature to be able to look at the upstream. In this particular case, this is a very clean plant, so you would also see, on a lot of plants, you'll see a lot of noise off to the left side that's coming in, and you're obviously trying to control the noise throughout the spectrum, but especially under those carriers. But in this case, it's a very clean plant. But again, that's the Upstream Analyzer feature. If you don't have that available and you're interested in it, just let us know, and we can have your business account manager reach out to someone there, and it's very reasonably priced if you don't have it. So that's the Upstream Analyzer. Nimble Spectra, or SpectraVision as we call it, this is included with Pre-equalization Analyzer, and this is your full band capture feature that reads the downstream spectrum from every modem that supports full band capture. So this is great. This is like having a guy with a meter out there in the field hooking up to look at the downstream spectrum, but you don't have to do that. It comes right through the modem. So again, you're going to tap on that, and it's going to ask you to select a CMTS. In this case, there's only one on this particular cable plant, this ARIS C4. And then it's going to tell you on that particular CMTS, it's going to give you the stats of what it's finding as far as full band capture. In this case, there are 864 modems on this particular CMTS that support full band capture. Full band capture is the feature, by the way, just within DOCSIS that, again, you can read or see the full downstream spectrum, that's video and data, that's passing through the modem. In this case, there are 864 modems that support that feature. It was able to poll 747, but not 117, and that could be for a number of different reasons. It just was unable to reach the modem at that point. It could be that the modem is so impaired that it's just not able to get that information, which is good to know. It shows you the number of impairments that it's found, and it does its best through various algorithms to try to figure out what kind of downstream impairments it's seeing. So, for example, it sees 180 suckouts, 269 adjacencies, 190 resonant peaks, 17 noise, and that's looking for something like FM noise that you'll see on the far left of the spectrum, where you probably don't have any channels there, but if there's FM noise getting in, it means that something's leaking in, and if something's leaking in on FM noise, other stuff may be leaking in as well, so that's good to know. Tilt, wave, roll-off, you don't see any roll-offs here. And then what you can do on this little screen here is you can just tap, and in this case, suck out, I believe is what I was looking at. And a lot of times it will categorize, when you're seeing those totals, it's looking at maybe a suck out, but not just an individual suck out. It might be a suck out and a wave and tilt and all kinds of things. Like here you see the first two are suck outs, and then you've got an adjacency, a suck out and a tilt, and then you've got a suck out, and then I don't know what the next one is. So a lot of times you'll see these combined kinds of impairments. And again, it's doing its best to identify that, to point to you some issues that it sees. And then you can look at the charts and determine, oh yeah, that does look like something we need to address. I think I went ahead and tapped on a suck out. Yeah, I did. And the suck, again, here's what you're seeing. So you see the time it was polled, the type of impairment, the CMTS and MAC address, and you see the modem vendor, and then you see the chart showing the suck out. And this chart you can use your fingers to expand or contract. In this case, let's say you expand it out and you can see a little bit better the suck out there. You also have the ability to look in the past and see how this modem was performing in the past, which is nice to know, is something that's been consistently going on. So again, this is a feature that's included both in the desktop application as well as in the mobile application of PreEqualization Analyzer. Geocoding, this is really nice to have in a mobile app. You can geocode, I believe, in the desktop application, I think. Yeah, I believe you can. But in the mobile app, obviously, it makes a lot of sense because it could be that you are at a customer location and maybe there, for some reason, you get a lot of times, might be in a rural area and you've got these rural routes where something doesn't geocode well. You put the address in the system, it's just, the system doesn't know what to do with it. So you may have to geocode it manually. And in this case, you can do that. Somebody that's right there at the location can tap on geocode, and it's going to fetch their location. So it's going to know exactly where they are. So they're standing there at the home. And then once it fetches a location, you're going to search for that modem, and then you're going to geocode that modem so that it then will show up in the map from that point on. Obviously, I couldn't show that because we don't have any modems here, but it was fetching where I am in my office. So that would not work here. Cable modem lookup, that's what you would expect. This is just kind of a standard query kind of function where you can look up a cable modem by various ways: MAC address, street address, IP address, customer name, that kind of thing. So you'd just be basically querying the modem. Work orders, another feature that is nice to have that's not always used by users of the PreEqualization Analyzer tool. A work order would be where somebody, like an administrative role, can assign work orders to technicians in the field that are using the mobile app. And for example, somebody that's looking at the PNM application may see that there's a problem that needs to be addressed. They may know where a technician is going to be the next day or who's going to be in that area. And they can, within the application, you'll see those little work order icons that you can click on, and then you can select a technician, and you can then basically assign that work order to them, and it pushes it to their mobile app. And then when they open work orders here, it will show them the work orders that they have. I again have an old screenshot of this, but this, because I can't assign work orders to anybody, unfortunately. I'd love to do that, but I don't have any cable modem plant or technicians to do that for. But here you see that you've got, the status of the work order, it's open, and then it can be selected in progress, and then later it can be fixed and closed. So, and of course, you scroll down, you'll see details of what's going on. I believe there's an option in there to maybe take pictures. So if you're making a a repair. Maybe you see that there's a corroded connector. You could take a picture of that to document what repair is being done. But it's a really nice feature within the tool, again, working in conjunction with the desktop application and the mobile application, to be able to assign work orders to somebody in the field and then have them be able to, in real time, update the work order, and then the person who assigned it in real time can look at those updates and see what's being done. So you can really keep track of the work that's being done, and it's, again, nice feature in there. Let's see what else. Nearby modems. So this is nice. I could not do this as well because there were no modems nearby me. I don't have any modems nearby me, but if you go ahead and tap this, it will first, again, fetch your location, and then it will show where you are in relationship to the devices that are in your area. So if you're in a particular area and you want to see who's nearby, you would tap nearby modems. Detail view is going to show you, if you want to look up a specific customer and see what's going on with their device and get a lot of detail about that device, that's what you'd be doing here. So you tap that, and it's going to pull up a list of all of the nodes that you have, and then you can select a node, and I just selected this very first one. And then when you do that, it's going to give you specifics about that particular mode. In this case, we see we've got a total of 59 cable modems on this node. 7 of them are red, 20 of them are yellow, and 28 are green. And then 4 are gray. I believe gray means that we were unable to communicate with the modem. So it's kind of in an unknown state at that point. There are no cable modems that are in a partial state. And then it's showing you that 16 of these modems are full band capture. So again, 16 of these modems would support looking at the downstream spectrum that would be passing through that modem. And then you would tap on any of these little arrows to the right to pull up that list of modems. In this case, I went ahead and tapped on the red modems, and I was able to see all of my red modems there. And then you can select a particular modem. And in this case, that's the MAC address of the modem that I pulled up, and you can see we've got 2 channels there. It looks like a yellow, one in the yellow state and one in a red state. And then as you swipe down, you can see at the top there the downstream information it also provides. So up at the top, actually, let me not gloss past that. So you've got the severity mode, but you've also got your in-channel frequency response, which is a PNM metric, and you've got your main tap compression, another PNM metric, micro reflection levels, group delay. You've got your in-home TDR. That's your TDR is kind of most likely related to in-home, near-home issues. And in this case, we're looking at 101 feet and 43 feet. And then your outside plant, or your VTDR, that would be generally indicative of a problem that's further out in the plant. And that's not showing a VTDR issue. So this looks like an in-home problem. There's no correlation group associated with this particular device. I'll mention correlation here in a minute, but that's meaning that this device, the in-channel frequency response and digital taps do not look like they match another nearby device. So we don't think that there's more than one device that's experiencing this issue, which is another somewhat of an indication that it's an in-home, near-home problem and not a problem affecting other devices further out in the plant. You've got your frequencies there. You've got your bandwidth, okay, 3.2, yeah. Then you've got your cable modem transmit power, and then your CMTS receive power is down at 0. I'm not sure why, but and then you've got, again, below that, you've got your downstream information. So you've got your downstreams and your frequencies, the power, the MER, looks like correctable code word errors on the correctable and uncorrectable code word errors as well that you can see there. When you swipe down, you'll see the end of that table, but then also next you'll see your in-channel frequency response chart. And again, if you've watched previous, or if you're familiar with the tool, or if you've watched previous videos, this is showing you kind of what the top of the haystack looks like. And generally what you want to see is a fairly flat signal, and one of them, the green one, is not too bad, but you've got the others that are into the yellow and very close to the red in this particular case. So you've got that chart to look at, and then as you scroll down a little further, you've got your digital taps. And this, again, would be showing an in-home problem. The tap number Or is it tap 8 is your main tap? Tap 9 is high, and tap 10 is high. They're not exceeding the threshold, but they're close, which is, again, why it's showing probably mostly a yellow, not quite red scenario in that, but again, showing an in-home problem. So a lot of times when these modems get really bad, when they're really red, you'll see that those taps rise above the red threshold line. In this case, they're not. Then as you look further out to the right, we don't see anything coming very close to the red threshold line. As you go further to the right on these digital taps, and you get a really high tap, that's going to indicate a more of a outside plant problem where you've got a longer echo cavity. And that's really what you're looking at there. When we go back, I'm going to go back a second. When we're looking at the TDR and the VTDR, really what those distances are is the echo cavity. It's basically the cavity that the microreflection is bouncing back and forth between. So what we're seeing here is, again, if you have a tap further out, like 13, 14, 15, and further, that would be showing a longer echo cavity in general. And then we swipe down a little further, and in this particular case, this modem supports full band capture, so as you look at the detail view, it's also going to show you the spectrum that it's identified here. You've got a snapshot of that. In this case, again, it's doing its best to identify some issues, and you see a couple of suckouts, and it's also showing a wave as well throughout this. In general, we're going to want a fairly flat spectrum, and I think it's seeing some up and down here. So this is, again, giving you kind of a hint where to look for issues or what's going on there. And you can see here also on the screen, when you come to the detail, you've got a geocode button down there, so you can geocode the modem if you happen to be on the screen, and then also you've got the install cable modem, so you can run the install cable modem from this as well. So you could be checking the readings and then go, okay, everything looks good, and you can click or tap that button to install that cable modem and generate a birth certificate for that. You also see you've got the cable modem history, so you can go back in history and see what this modem was looking like on prior days. And then lastly, we've got the signature icon, and this is really for your correlation groups. Again, what a correlation group is where the application has identified that there are more than one modem that have the same kind of signature. When you tap that, you'll pick a particular, if there's more than one, you'll be able to select a correlation group. In this case, it's identified at this correlation group at this particular node, and we see the in-channel frequency response, and this is actually multiple modems that all look very similar. So the application is looking at the pre-EQ data from these modems and how they're adjusting the frequency response and the digital taps, and it's saying, you know what, these are adjusting their readings in almost exactly the same way. And if that's the case, if you've got multiple modems doing that and they're all geographically close together, it generally means that they are compensating for the same upstream impairment. So there could be a corroded connector on a tap somewhere, for example, that maybe connects 3 or 4 modems. And even though the modems are all different distances from that impairment, the echo cavity that's creating is the same distance. So, one modem might be 900 feet away, another might be 700 feet away, but it could be that the echo cavity is going between that corroded connector and some other, like an amplifier or something, and then that echo cavity is the distance that you're looking at. So in this case, we see the in-channel frequency response, again, looking the same for all of these modems, and as you can open that, and you can pull up a map, and you'll see again that you've got, in this case, I've got 3 showing. Probably if I expanded it, there's probably a 4th modem there. It looked like there were maybe 4 lines on that ICFR chart. In this case, you've got your modems that are in the correlation group, and then you see your gray modems. Those are modems that are not in the correlation group, so you can always look and see where your first good modem is versus your last bad modem, and then you can kind of determine what's in between there, and that gives you a good hint on where to look for that impairment. So again, that's your signature tab. So that's it. That's what it looks like in the Nimble PNM app. Again, it's a great tool to have. It's nice to be able to look and be in the office and and look at all of these things, but you've got many of the same features available in the mobile app for your technicians that are out in the field. So if this video was helpful for you, I hope that you will go ahead and subscribe. Just down somewhere in YouTube there, you'll see the subscribe button. Go ahead and subscribe to our videos and give it a thumbs up. Ring the little bell if you want to be notified whenever we're live. I will be back. I won't be back next week because next week is Thanksgiving week. So we're going to take a break. Tech Tuesday is taking a break for Thanksgiving week. But I will be back the Tuesday after that at 3 o'clock Eastern Time. And I hope to see you then. Bye-bye.